In this lesson, we're going to define quality and we'll apply it to finding other properties in our saturated mixture region. So let's talk about what quality is. We refer to quality, which is the symbol X, as the mass fraction of vapor. So when we say the mass fraction, we're talking about the mass fraction of vapor per the total mass of the fluid involved. So the fluid you could have of the water could be vapor, excuse me, not just water, because it could be any substance, but the fluid of the mass of your substance could be in vapor form or liquid form. So that's your total on the bottom. But we're just concerned with the vapor portion of that. Our quality is an intensive property, but is an intensive property that is only defined in the saturated mixture region. So obviously it can't exist outside the mixture region, because outside the mixture region we don't have a fraction of vapor. You either have more than 100% vapor. You have 100% vapor, it's either all vapor, or you have no vapor and it's all liquid, so there's no fraction. So it's only possible to exist inside of the saturated mixture region. So let's look at this graphically on the vapor dome. So here we have a vapor dome, which is depicted temperature versus specific volume. It doesn't have to be specific volume on the bottom of our chart. We could have used enthalpy or entropy, but we're going to stick with specific volume for this example. So we draw our constant pressure line. And if we look at our saturated temperature, depicted here as T1. Alright, so we're at saturated temperature. If we're at saturated temperature, then we know we're somewhere inside the mixture region. Okay. So we have our quality, which we'll say it's specific volume 1. Right? It's somewhere between the saturated liquid line and our saturated vapor line. Now, saturated liquid line, if we were on there, it'd be all liquid, so that means the amount of mass vapor would be 0, so the fraction would be 0 over 100, or over all of it, so it'd be the fraction would be 0. Whereas if we were on the saturated vapor line on the right side, well then all of our fluid would be in vapor form, so therefore it'd be 100%. So your quality is going to range from 0 on the saturated liquid line to 100% on the vapor line. So we denote in our water table, our steam tables, the subscript F is for the values you would find if you were on the saturated liquid line, and the subscript G is the values you'd find on the saturated vapor line. One way to help to try and remember this, F for fluid. I know all of the everything we look at is a fluid, whether it be gas or liquid, but for the liquids the F is what we use, and then for the vapor you can look for the subscript G for the gas. Okay. So they will have, if you go into the water tables, steam tables, excuse me, they will have values for specific volume at saturated liquid and specific volume at saturated gas. Now, if we use table 4.1 from our text, we have these quality relations. So in this case, if we're dealing with specific volume, we would look there and see that our quality would be defined by what our specific volume is minus our specific volume at saturated liquid all over our specific volume at saturated vapor minus the specific volume at saturated liquid. So we're saying it's a mass fraction. So we're saying how much of it is in the vapor form. So if it's going vapor as it's going to the right, we see how far it's traversed to the right divided by the total amount it could traverse to the right. And that will give you your fraction of your quality. Okay. There's also a term for enthalpy. You can see down here we have enthalpy Fg. This is your enthalpy of evaporation. This is really, and you can kind of see by the equation above it, all it is your enthalpy at saturated vapor minus your enthalpy at saturated liquid.